Hello, everybody. Welcome to another episode of Network Buzz, a Lake Tech podcast, where we try to bring some awareness of new technologies in the IT space and try to bring some expertise from the Lake Tech perspective. And talking about today, we're going to bring up Wi-Fi 7. We got Phil back on the mics here.
Hello.
Phil, how's it going?
Good. How are you, sir?
Good. It's been a minute.
Yeah.
Last recording was like mid-December, I think, talking about some things we posted. So it's been a minute of us getting on the mics because holidays
Sure
are
has.
the holiday rush.
Yeah.
Kills us.
I'm excited when you get back in this groove.
I know, me too. Despite the fact that it looks cold in here, Phil, judging by your attire.
Well, I think
And it is cold.
I think maybe the heater isn't doing what it needs to do, but yeah, it's cold.
0 degrees outside will
no,
do that.
It is 0 now. It was -8 when I got up this morning.
Yeah,
and that's
I know.
real feel, not wind chill.
Yeah, and we won't do weather analysis, but I will tell my little story of how shoveling the driveway. Black ice.
Yeah.
Oh, I went
Ooh.
full feet overhead, fell, and I can't believe I survived. Like, I didn't know what whiplash felt like until I took that stumble
Wow.
the other day.
Wow, that's no fun.
Came in, it was just like, all right, I need a minute. Kids, hang out over there. I need a minute.
Yeah, I'm sure you're not alone in that. I mean, ice and just winter shoveling in general, people have heart attacks. I mean, it's a dangerous weather.
Old man stuff.
Yeah.
Let me tell you.
Yeah.
Sorry,
That's why I don't
silence the
shovel
PC.
anymore.
That's probably the right solution, but apparently not for me. Okay, but yeah, anything else? How was the holiday then for you? Anything
It was
to
good.
report?
It was relaxing. You know, spent a lot of time with family. You know, good food, good family. You know, stayed local this year for half the holidays. But yeah,
Yeah, same with us. I mean, again, the little kids, Christmas.
cool.
They
Cool,
get all
cool.
that belief, Santa, and I love that. And Santa does exist. Don't worry, everybody. But yeah, it was good stuff.
Yeah, I'm excited about my dry January though.
Yeah, I was gonna say it's usually Network Buzz that we started doing where we talk about some local beer and things like that. As we are a couple of beer drinkers, just like when I was on with John. But yeah, dry January. This is the dry January version of the Network Buzz.
That's right.
But yeah, we would be. I mean, I know I have some Masthead hazy IPAs sitting at home. Masthead local brewery here in Cleveland. They produce some of the best stuff in the country when it comes to IPA perspective. It's really, really good stuff.
That's a good plug. I'm sure they
you know,
appreciate that.
regardless, I know I gave you some because it's that good.
Oh, is that what's in my fridge that I haven't
yes.
been able to try yet?
That's what you have ignored. Yes, for 3 weeks now.
Yes. Yeah, I'm excited. We've got some Conway's Irish. It's a stout.
Time of year. A
Yeah.
stout?
So they have a stout out now. So I have that at the ready.
It's usually the red ale time of year with that.
Yeah. They have the Conway's Irish Ale, which I have that as well. But I'll try an ale and a stout side by side.
Like,
A little comparison
underrated
test.
take on Great Lakes. Conway's might be their best beer.
Oh, you think?
Yeah. I mean, Great Lakes gets all the pub and there's all like the standard, your Elliott Ness and your things like that.
Sure.
Conway's might be their best beer.
Yeah. I mean, it's good stuff. You know me, I'm kind of stuck on IPAs, but I can easily set an IPA aside for a
Conway's
Conway's.
is solid. It's
Yeah,
good
no
stuff.
doubt.
It's good stuff. So yeah, we're looking forward to February 1st.
Yes.
But again,
We sound
today,
like is that an alcoholic statement? I mean, that's
I mean, come on, everybody has a hobby. Jeez, oh man, Phil, don't turn us that direction.
all right. Sorry.
Oh, good.
And
Oh,
go
good.
on.
Yeah. Well, today we're talking about Wi-Fi 7. I know we teased this, back in. I looked it up. It was like, October when we had our, evolution of Wi-Fi and talk about different standards, whether from security protocols and, how wide the channels are and whatnot through different standards. But today we're going to finally dive into Wi-Fi 7. And if anybody's paid attention to the YouTube channel here at Lake Tech, you've seen that Phil actually put out a video in diving into Wi-Fi 7, kind of introductory, high-level type of conversation, but you also did some testing across different devices.
Yeah.
So we're going to dive into kind of your take on what you discovered and through your research there and those that 20-minute video you put together, which was really good stuff. The camera work especially was really, really good. But we'll talk about
New skills being learned.
yeah. As we are. But there's a lot of features Wi-Fi 7 brings to the table.
Yeah.
We're going to talk about multi-link operation. We're going to talk about static puncturing as I'm reading my notes. And of course, a lot of other features and functions that Wi-Fi 7 can bring. But we'll just go high level, Phil. Wi-Fi
Sure.
7, like what did you discover? How was that experience? Kind of just start from there.
Yeah. So super awesome. As we talked about in October, I was waiting for gear. That was one of the hardest things to obtain was actually getting a Wi-Fi 7 AP. And I was fortunate enough to get the Aruba's flagship AP, the AP 755. So I had full capabilities at my fingertips. Not that the 735s, couldn't have done all the same stuff, but I like having the big bad boy in the room.
I was going to say, what, did it weigh like 35 pounds?
No. I mean, it's not crazy heavy. I mean, it's definitely bigger than the 735, but I would say it's on par with the 655. It's not
because it has what 2x2 radios for all the bands.
It's 4x4 in all bands.
4x4
yeah,
in all bands.
755.
Okay.
Yep. Same as the 655.
Okay.
But yeah, so I got that, and we were able to source an Ekahau Sidekick 2, so I was able to do 6 gigahertz spectrum analysis. So I was waiting on that as well. And then, yeah, I as you'll see in the video, I sourced a bunch of the current day enterprise cards that are being shipped in laptops. So as you start, buying new laptops today, they're Wi-Fi 7 ready, you're going to see that there's going to be Intel BE200s in there, or the MediaTek 7925s or 27s. So I think it's really exciting to get into this analysis, because we're going to see, what's being brought to the consumer today and tomorrow. I think these are going to be the standardized chipsets, driver enhancements, moving forward.
Well, and that's what we want to do is, talk about, I mean, I know you referenced this, but like the data sheet that comes to like what is Wi-Fi 7, and it's like top end, capacity and throughput and all that, but real life scenarios. Like that's what we want to talk about, and the input and the impact we want to have doing this series is talk about, real world scenarios. Is it working? What clients can use that frequency band, things like that.
Sure.
So I know you said you in the video you had 4 different chipsets that you're going to be testing throughout this process.
Yes.
And just a quick summary, everybody can go watch the video and find out how it all went down. But let's just talk about Wi-Fi 7 and the experience that you had.
Yeah, absolutely. I mean, I think it'd be good to start off with, again, the major features, which again I highlight in the video. But let's talk about MLO. Yeah. And I think we should break this in 2 pieces, right? What is beneficial to the enterprise and what's beneficial to the consumer? And I think right up front, the 2 big things that are beneficial to the enterprise is MLO and the spectrum puncturing. Whereas the 4K QAM and the 320 megahertz wide channels, that's more beneficial to a home consumer or a small business that's only got a couple APs, or it can be very near their APs. So I think that should be clear, is that a lot of the excitement that may be around Wi-Fi 7 and the super fast speeds that you can obtain, you can only really obtain those in very specific environments, like a consumer home environment. Yeah, so getting into the MLO, so the multi-link operation. That do you have any specific questions on that, Mike?
I mean, it's interesting. Again, we kind of prepped for this and talking through. That's why I'm just going to let you go through what it actually means, because most of the time you sit on one frequency as an end user on your device, and you jump on and off the network as that device, and when you view that as a consumer, all you see is just well, Wi-Fi is not fast, it's kind of going slow. Yeah. But what does that mean, and what can multi-link operation do to assist that on Wi-Fi 7? All
right, yeah, cool, yeah, good lead in. So when we talk about 2.4 and 5 gigahertz, and even really 6 gigahertz back in Wi-Fi 6 or 6E, we discussed in the last podcast that a client is only associated to one given band at a time. So if they were to shift bands, say from 6 to 5 gigahertz, that's a roam. That's a roaming condition. There's some latency and other things built into that, where once we start talking about MLO with Wi-Fi 7, we can have clients that are associated to either 2 or 3 bands simultaneously. And that brings lots of benefits from, being able to have faster throughput, because maybe some clients are able to put those 2 bands together and realize the throughput gains through both of those. So let's say we're on 2.4 on a 20 megahertz wide channel, and we're on 6 gigahertz on a 160 megahertz wide channel. So now we've got 180 megahertz worth of channel space for bandwidth, and some clients, and we're going to test each one of these clients, can take advantage of that and actually use those for simultaneous transmit and receive. So you're going to see that in the videos. And so that's one important reason to be on both bands, but really the more important reason, in my opinion, is the ability to shift from one frequency band to another. So as a client is associated to, say, 6 gigahertz and 2.4 gigahertz, the analogy we were talking about earlier is, we are now kind of on 2 highways at once. And some clients are, kind of using one highway, let's say 6 gigahertz. And if there is latency or congestion or interference on that band, they have the ability to dynamically shift all their traffic over to 2.4. Change lanes, yeah. So maybe, and we're assuming 2.4 has lower latency, but the fact that we have 2 bands to choose from, or maybe 3, some of the clients can be on all 3 bands at the same time. They can choose the band that's going to give a better experience for the end user. And where that's really important is things like Wi-Fi calling, video streaming, very latency sensitive applications that suffer from, congestion or interference, or, anything that's going on within the channel that they're currently on. In Wi-Fi 6 and below, the only way to get around that of course, you could use QoS mechanisms to help with that, but that's not going to help with interference and, other incumbents on the band. They would literally have to shift. They'd have to roam over to the other band because they don't have a connection to it. Where Wi-Fi 7, they don't roam over to it. They're already connected, and they just start using that other band for their send and receive. Or potentially they're sending on one band and receiving on another band. I believe one of the operational modes allows that. Don't quote me on that quite yet, but that'd be something I'm going to dive into in some of the analysis.
Yeah, that's interesting that it just dynamically does that kind of stuff. I mean, some would call that AI. In the AI world, it's like, oh, it's automatically done then. It's AI.
Yeah, sure.
Like,
yeah.
So is autocorrect.
Sure, yeah. It's algorithms for sure. Yeah, so, in the enterprise space, I think that's the most exciting feature because we will see real world benefit from that. So obviously you have to have a Wi-Fi 7 capable chipset. And Wi-Fi 7 capable APs, of course. But once we get there, I think we're going to have better experience in Wi-Fi in general.
Yeah, I mean, a lot of places I assume don't have Wi-Fi 7. I know it's obviously once the hardware is out there, therefore it's capable.
Yeah.
Only a couple devices can do that right now, but that's what a couple of, like an iPhone and a couple of PCs, but not stuff that's like really in the general public right now.
Yeah, I mean, it depends. If you're buying equipment today, you can buy Wi-Fi 7 enabled laptops, and that's some of the chipsets that I'm testing are the chipsets that are in those laptops.
Okay.
So like the MediaTek, I was looking at I forget who it was. I think it was Dell. I forget who I picked, but I was looking at, one of the, it was a Surface. I was looking at the Surface of the Wi-Fi 7 enabled. I think it was a Surface that they're using the MediaTek chipset. I have two MediaTek chipsets that I'm testing, the 7925 and the 7927. And they had, I believe, the 7927 in there. I had my buddy just purchased a brand new PC that has M2 slot on board, populated with a Wi-Fi 7 chipset, and it also had a MediaTek installed on there.
Okay.
So these are, real cards. And it's really exciting to dive into the analysis.
Yeah, for sure. We talked about MLO briefly. You want to dive in with stack puncturing and just lay it out because there's the fact that there's 320 megahertz wide channels. I mean, they're all the features that come with Wi-Fi 7. Let's just start diving into that.
Okay, yeah. So the next big one is the static puncturing for the enterprise. Now it works for home consumer as well, but I see more benefits. You can actually realistically benefit from it in an enterprise deployment. So spectrum puncturing, also called static puncturing, also called preamble puncturing. There are several
spectrum puncturing makes more sense.
It does make more sense. And I think I explained what preamble puncturing, why they call it preamble puncturing in the video. So go watch that. But yeah, spectrum puncturing is, I think, a better term for it. So what it is if we have a wide channel. So let's talk about Wi-Fi 6 for a moment. So if we have a wide channel, let's say it's 80 megahertz wide. So we have stitched together 4 20 megahertz wide channels to come up with 80 megahertz. So in Wi-Fi 6, get my numbers straight here. In Wi-Fi 6, if we have a single user consuming that channel and there's interference in just a 20 megahertz piece of that channel, the AP will puncture or eliminate the ability for the client to be able to transfer data on that 20 megahertz wide channel. And in Wi-Fi 6, it actually eliminates the ability for the client to transmit on most of that channel. And I'd have to look it up, but it's either it falls back to a 20 megahertz wide or potentially 40 megahertz wide. It might allow you to use the full primary part of the wide channel, or maybe just 20 megahertz.
Is that part of the initial configuration when you're updating the Wi-Fi settings, what have you? Yeah,
it's part of when you create the wide channel. So when you make it a 80 megahertz wide channel, just the AP already knows, hey, 40 megahertz of this is what I'm going to call the primary channel. The other 40 megahertz I call the secondary channel. Okay. So I can't remember in Wi-Fi 5 that client's going to fall back to 40 megahertz of the primary or 20 megahertz of the primary. Okay. Irregardless, that single client will not be able to benefit from the remainder of the channel. So we've only punctured out 20. There's 60 left, but it can only use either 20 or 40. And I believe it's 20. So enter Wi-Fi 7, and we have a single client on that same 80 megahertz wide channel, and let's say we lost 20 megahertz of it. The client can actually use the remainder of the wide channel on either side of what has been punctured. So it can continue to use 60 megahertz wide of that channel. And that's important because we always want to get our users on and off the wireless medium as quick as possible, because that reduces channel capacity, which increases, your overall usability of the AP. So which is a good thing. So the difference between Wi-Fi 6 and Wi-Fi 7 is that we have the ability with a single user connected for them to steer around that puncturing. In Wi-Fi 5, you could take it. I'm sorry, Wi-Fi 6, you could take advantage of multiple users on that wide channel where they could use pieces of it, but it's smaller pieces. None of them consume the whole remainder of that channel. So that, in a nutshell, is spectrum puncturing, preamble puncturing.
Yeah, and again, it's just
Static function.
efficiency of the network at that point. It's interesting. I know we talked about like IoT devices and those devices that are using small pieces of that frequency band, but it's
the RUs.
yeah.
Yeah, so I didn't want to get too technical, but it's actually we're taking
Get
them.
after it.
Yeah, so in Wi-Fi 7, we're taking those RUs and we're making them a little bit smaller. So now on 20 megahertz channels, and I'm not going to try to cite the numbers. Let's just say in Wi-Fi 6, a 20 megahertz channel would be subdivided into, let's just say, 40 RUs. It's probably somewhere around there. So little bitsy pieces of it so that you can have clients use those little RUs so you can transmit to multiple clients at the same time. So huge benefit in AX to be able to do that. So in Wi-Fi 7, we take that a little bit further where we make those channels a little bit smaller. So now we have more channels on a 20 or more RUs on a 20 megahertz wide channel so that we can assign those RUs to even more clients or allocate those RUs a little bit differently. So when we talk about spectrum puncturing, or actually when we put together wider channels, we put together 40 megahertz wide channels. We go from, say, the 40 RUs to 80 RUs or more because we don't have the space in between the channels that we need to protect against. So we can have RUs all through that. So it might be like 90 or 100 RUs on a 40 megahertz wide. You jump that up to 80, you have 200. So, and I apologize, I said they made them smaller. So on a 20 megahertz wide channel in Wi-Fi 7, instead of 40, again, I don't have the numbers at my fingertip, but it could be 80 RUs. I don't think it's quite double, but it might be. So now on a 20 megahertz wide, let's just say it's 80, 40. Now we have 160, but more. We probably have like 180, maybe 200. And it goes on and on as you get through, as you keep on combining channels together for channel bonding. Yeah. So when spectrum puncturing comes into play, those RUs are allocated specifically for all those clients, and they call it MRU, or multi-resource utilization, or
multi-resource units.
Thank you. Multi-resource units.
We
So,
prepped.
yes. Yeah, so Wi-Fi 7, they call it MRU. They call it an MRU, I think, in the combination of making those a little bit smaller, and we take advantage of the MRU when we do the spectrum puncturing because we can allocate the MRUs differently in Wi-Fi 7 to allow them to steer around that interference for a single client. And it's also advantageous to multiple clients, but it was advantageous to multiple clients in Wi-Fi 6 as well.
It's very granular. The more I hear about it, like every feature set, everything utilizing full band.
Yep.
Being able to puncture different spectrums throughout. I mean, it's just funny how that's like, I think of like a server environment where you go virtual as opposed to have one server runs one application. Now and they go VM, and then you can use different parts of the VM. And that's basically the comparison as to what it's doing then within Wi-Fi spectrum.
You got CPUs and sockets and threading and everything else that continues to subdivide that up.
You have all these resources. How do we use all of it?
Yes.
Right, and it's great. That's not just faster throughput. Put this out because it's faster, but how do we use the space more efficiently?
Yes,
which is great stuff.
Yeah, that's AX. That's HE, high efficiency.
There you go. An acronym I didn't know was part of it, but we found there.
Yeah, and make it clear. So yeah, AX is it's 802.11ax or HE. Or Wi-Fi 6, or Wi-Fi 6E if you had 6 gigahertz to it. So all sorts of words. And Wi-Fi 7, we call it Wi-Fi 7.
Get technical, Phil. Come on.
Or 802.11be. That's the name of the not the amendment, but the not the ratification.
I want to say code name, but it's probably not.
I can't believe I'm drawing a blank on that. But it's 802.11be through the IEEE, and it's Wi-Fi 7 through the Wi-Fi Alliance, or it's also called EHT for extreme high throughput.
Okay.
So where Wi-Fi 6 was HE, high efficiency, Wi-Fi 7 is EHT for extreme high throughput, which also does the efficiency stuff.
And then Wi-Fi 7E, is that the next iteration?
No, there's
extreme high.
Yeah, there is going to be a part 2. I don't have the specs on it, but yeah, there will be a part 2 to Wi-Fi 7 as well. So like AX came in 2 parts. It came in Wi-Fi 6 and Wi-Fi 6E. So it was like part 1, part 2. Kind of like AC wave 1, wave 2. Don't know if they're calling them waves in AX and in Wi-Fi 7, but yeah, there will be another release in the future for some of the things that they couldn't fit into the amendment.
Sure.
So
Okay. And we also talked about how like the conditions of which you get to Wi-Fi 7, utilize Wi-Fi 7. You know, like the WPA3 enabled devices, and like so. Let's dive into some of that because as you found, like some enterprise authentications cannot take place then on Wi-Fi 7.
Yeah.
So go there.
Yeah. So it's all spoiler alerts for the video, which is a good thing. Gives you something to look for. But I stated in the summary of my video that when I was doing my initial testing of these cards that I obtained, these Wi-Fi 7 cards, I actually couldn't get MLO to work at all. I had, you know, Windows 11 24H2 applied, which is required. That's where Windows allows MLO operation, but I couldn't get it to form. So lots of research, and what I have found was that they wouldn't form if I was doing an enterprise 802.1x enterprise authentication. It only, so they would associate. So you could do 802.1x, you can authenticate and you can get associated, but you would just be using the channel without MLO capabilities. So not multi-channel or multi-link, which is multi-channel, which is multi-frequency.
Love it.
Yeah, thanks. So it would not take advantage of the MLO capabilities. But once I associated it and authenticated with a pre-shared key, that's when everything lit up, everything worked. So it definitely looks like a deficiency either with Windows. Maybe deficiency is not a good word, but it's either a Windows issue or a client driver issue. So my iPhone, however, which is not Windows based, I could do an 802.1x enterprise authentication and it would form MLO. So it would form MLO whether I do enterprise or personal or pre-shared key. So no matter what I did. So that narrows it down to drivers for the other clients or Windows itself. So once I find that out, you know, I'll definitely do a posting on it because it's really important, because if we're talking about Wi-Fi 7 in an enterprise environment, most enterprise environments have an SSID that's 802.1x enabled, so we can do ETLS authentication and, you know, do secure authentication. If we can't get MLO capabilities in combination with that, it takes away one of the major features. So
no, of course.
Yeah. So
But
I will have
there's,
more on that.
There's more testing coming. I like you only worked through one of the chipsets in that first video, so I know there's more to come.
Yeah. And to be fair, I did test a couple of them just really quick, just to make sure that they could associate and authenticate. And yeah, they did. I actually tested all of them for 802 and yeah, spoiler alert. I already tested all of them with enterprise authentication, and none of them would come up with MLO.
Okay. Trying to think anything else in notes here. We got to talk about 4K QAM.
Okay, yeah. So 4K QAM. So getting into the consumer space, I would say, because 4K QAM. So 4096 QAM. I'm not going to try to recite the word like I did in the last post. Quadricure.
Nope.
Blah blah blah. I'm not going to do it.
Nope.
So with Wi-Fi 7, it's 4096 QAM, and that's a quadruple step up from Wi-Fi 6 or 6E, which was 1024. So what does that mean? That means the modulation has increased and more dense, so that we can get more data in the air all at once on any given frame, right, or any given preamble. So that means that we can get much more throughput out of a client that can modulate at 4096. But you need to be like feet away from the AP in order for it to do that. As soon as and I'll actually do this. I'll do a little test to see how far or how close do I need to be to the AP to actually get 4096 QAM. So I am going to do some videos on throughput QAM. I'm actually going to do some speed tests because I think it'd be fun to see how fast these clients can go with ideal conditions.
Well, real life stuff. Yeah.
Well, or not real life stuff.
I would rather see real life stuff. I mean,
yeah, we're going to do real life too.
Here
of
is
course.
like the peak of the peak of the mountain. This is what we can do, but in all reality, what is the auditorium and classroom setting and office setting, and what does that really look
so,
like?
Yeah, so it's just more data in any given frame because of the modulation type, which is never going to be realized in an enterprise environment, because the closest you're ever going to be is an AP on the ceiling. All right. Maybe in a res hall, maybe they're laying up against their little res hall AP. Maybe they'll get 4096 QAM with something they have very near that. That's possible. But not realistic in the enterprise environment. So when we look at these numbers on 36 gigabits throughput or whatever those numbers are, that's taking into consideration that you're modulating at 4096, which in the enterprise world, it's not real.
And sticking in the dorm setting, I'm curious when Wi-Fi 7 enabled like gaming devices, and we talked about like latency being a thing that's going away.
PlayStation 5, I believe, is Wi-Fi 7 enabled.
Yeah, because I know anytime you talk about an environment, take a res hall environment and the latency, so like the ping rates and things like
Yeah,
that.
yeah,
And I wondered if Wi-Fi 7 would fix some of that because of the agility of moving between lanes on the highway.
Yeah, I would hope so. There's no reason why it shouldn't, because if it can form MLO, then by all means, it has the capabilities of jumping over, not jumping, it's already there, shifting its transfer to the uncongested frequency.
Yeah, the true test of the network is, get Call of Duty on Wi-Fi 7 and see how they do there. That's the true test, honestly.
Yes, sure. Yep.
Okay. Anything else you want to talk about? I mean, I got notes about like randomized MAC address is a requirement of Wi-Fi 7.
Yes.
Is there anything else you want to talk about, like requirements? Because obviously, I think we got to get the rest of the network up to speed in order to take advantage of all this.
Yeah, and I think that's a good place to leave it. So Wi-Fi 7 does require the ability for MAC address randomization. I got a little bit more research to do on that, but it is a requirement for Wi-Fi 7, whether that's in 6 gigahertz or 5, all 3 bands. I don't know. I'm going to do a little more again research on that. But that leads into, our current day device. Now, not talking about Wi-Fi 7. Our devices today are starting to implement Wi-Fi or MAC address randomization, especially the new releases on iPhone and Android. So with iPhone release 18 dot something, it will scramble your MAC address on an SSID every 2 weeks, unless you go and manually disable it. But that's going to be a big problem for environments that are using MAC caching for some of their clients on the network. So this is very popular in universities, where the student will onboard their device onto a guest network, and when they do that, they say, hey, I'm Phil, I'm onboarding my device, and that MAC address is recorded in the system, so that the next time they connect, they're like, oh, that MAC address is Phil, we're going to go ahead and allow them on the network, no captive portal pop, and allows them to share their device and whatnot. So once that MAC address randomizes, that's going to be a problem, because they're going to connect and it's going to pop a portal like it's a brand new device. So there are technologies out there that we can work around that or work around it. It's really, a privacy enhancement that the vendors are pushing, like all of this, like WPA3, like, ETLS requirements, things like that. So, the manufacturers, the vendors are pushing this technology to further secure our networks. And I get it. But we have to talk about what does it mean to you, and what are our solutions.
They put the onus
it.
on the user then to and it's a pain in the butt. They don't view it as, I'm increasing my security. No, it's a pain in the butt.
Yeah, just not realistic. So I think our next session, or our next Network Buzz podcast, will be talking about personal wireless networks and how we address that.
Yeah, that's big time.
Yeah.
Be able to, and no more lists of devices that just don't bother to bring your Google Home because it's not going to work.
Yeah. That's what it comes down to. And the PWN definitely works around that.
Yep. We'll get there. Cool. Anything else I missed? All my highlighted items are taken care of.
Yeah, I didn't read my notes. Let me read my notes. Client differences. So I'm going to do, and you'll see, I'm going to do a individual video of each one of those cards just to show how does it use MLO, because there's lots of modes of operation. Lots of different modes of operation. Can it actually simultaneously transmit and receive on 2 bands? Some can, some can't. So we're going to do some videos on that. I think it's about the only thing that we didn't cover. 320 megahertz wide channels. We briefly discussed it. But the Wi-Fi 7, we go from 160 to 320 megahertz wide channels, which is a huge swath of bandwidth and frequency space, by the way, that really isn't realistic in the enterprise world either. Because once we enter 320 megahertz wide channels, you can only have 3 of those across 6 gigahertz, and it's only capable in 6 gigahertz. And you're not going to do that in the enterprise. That means if you have more than 3 APs near-ish one another, they're going to be overlapping. You have co-channel. You're back in the days of 2.4 gigahertz. Yeah.
Well, I feel like it's more like how many 40 megahertz wide channels, how many 80 megahertz wide channels. Like that's the big stuff.
Our go-to is going to be deploying 80 megahertz wide channels. Where our go-to today is 20, maybe 40 where we can get away with it. Now it's going to go-to is going to be 80 and maybe 160 where we can get away with it.
Yeah, that MLO and spectrum puncturing, those are that's the big boys. Those are the big issues that this is all coming through.
Yep. But well, in 6 gigahertz, honestly, making those channels larger is a real world thing. But we can do that with Wi-Fi 6E today. That's not a Wi-Fi 7 thing.
Correct. Yep. Cool. Good stuff.
Yeah, I think so.
Yep. More videos to come.
Yep.
If you haven't, go watch Phil's video going over in a Wi-Fi 7, have an overview perspective and testing that. I think it was the Apple chipset as the first one.
No, I did Qualcomm.
Yeah, Qualcomm.
Yeah, so I did the overview of Qualcomm. I am going to do the dedicated video on Qualcomm as my next video.
Okay.
And then I'll probably steer to Intel, then iPhone, and then over to MediaTek, I think is the order I'm going to go in.
Okay, good stuff. All right, we'll wrap it up there.
All right, cool.
Thanks everybody for watching Network Buzz, a Lake Tech podcast. Please go check us out. Keep watching. Really appreciate everyone taking views and, taking a look at all the stuff we have to offer. If there's anything else or any ideas you want us to dive into, again, don't hesitate. Reach out, comments, reach out to us. And if you're watching this, you probably know how to. So thank you everybody for your time. Really appreciate it. And we'll see you on the next episode.
Yeah. Stay warm.
Yeah, right. Don't slip on the ice. Yeah.